far from you.
Wouldn't you? Doesn't it make you feel more relaxed around the wallet area?
I really trust you.
A tie. You have to trust the tie. You don't have to trust me. No, don't trust me. I wouldn't ask you to trust me. Trust the tie. It's a nice tie.
Oh, yeah.
Well, if you folks are ready, I'm ready here.
You're ready?
Recordings are going, so we're up to speed.
Awesome. You ready, Justin?
Yeah. Let's do it. Yeah. Ready?
Yeah.
Yep.
Okay.
3, 2, 1. Disclaimer. Throughout the whole of human history, many exciting inventions and interesting developments have taken place that shaped the future. A future that hadn't happened yet, but has since long passed and is now lumped into history as old news, such as the first attempt at cooking a hot meal. May have ended badly. Who knows? Other attempts at discovery were evidently successful, as cooked food is commonly enjoyed today. The first painted symbol that became a word may have become the first spoken word uttered by the first critic. The expansion into critical words of communication, language, logic, myth, mathematics, into the wheel, the plow, the air conditioner, which is very handy today because it's like 105. The electronic age of mass communication in which we're all like here right now checking things out. History is full of giants who built the world that we now live in. And there are still more people with sprained ankles than there are people on the moon. What do I mean by that? Well, mankind's earliest attempt to reach the moon took place before dawn, reached an altitude of approximately 3 feet, and resulted in a sprained ankle. There's still much gianting to be done, which is why each week we celebrate the work being done by the future giants of the world here on This Week in Science. Coming up next.
I've got the kind of mind I can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science? Good Monday, Kirsten and Allie.
Hey, Justin. Welcome, everyone, to yet another This Week in Science. We are here, episode 272 by my approximation at this point in time.
Really?
And yeah, I've been counting for on all of my fingers and toes.
A lot.
It's a lot. They keep going. It's good. We're working it once a week. We bring the science. And so I hope you are here to watch everything that we've got going on with Justin and Allie and me. We're having fun. And on today's show, we have science news, like usual, right? But I brought stories about GM fish, This Week in Science history, and QE and DNA. What do you have, Justin?
Wow. I have got a robotic fish. I have another reason to kill your television. This one with some urgency. You need to do it now while you still can.
No!
I have a dangerous driving condition and a potentially everlasting tomatoes with only one side effect. Or one slight, maybe. They'll be good, I'm sure.
I can't wait to hear about it. Allie, what did you bring?
I've got bubbles for cancer and bedtimes for the Japanese.
Putting them to bed. All right. Well, it all sounds so enticing. I want to hear it all now. So let's get started. On with the show, right? Science. You, yes, you, are held together. Your DNA, the stuff that makes you, is held together possibly by quantum entanglement. Isn't that crazy? Yeah. Some physicists publishing in the archive.org database of articles and scientific ideas. Elizabeth Riper at the National University of Singapore and some people she works with have been looking into the idea of quantum entanglement and what role it might actually play in DNA. Because we have this whole idea, the classical model, the standard model of physics, and we have everything holds together on the macro scale. But the smaller and smaller you get, there are these questions of how does this tiny quantum stuff that we know about now, how does that tie in to the bigger stuff? And so, we've been finding the possibility of quantum entanglement in photosynthesis. And we've been finding the possibility of quantum entanglement in how birds are able to navigate and migrate, that somehow quantum entanglement has something to do with that. And so now these researchers have come up with a new idea in which they take the idea of entanglement. Entanglement is this process. So you have, for any object, say an atom or a nucleotide in DNA, you have a wave function. And the wave function is basically a wave of probability. And it's the probability of anything existing in any point in space. And so when a single wave function describes two objects, those two objects are entangled. They share the same existence. If something happens to one, the same thing or similar thing is going to happen to the other. No matter, they could be on Mars and here on Earth super far apart, or they could be right next to each other. And it doesn't matter because they're entangled. So what does this have to do with DNA? These researchers came up with this simplified model of a nucleotide, where a nucleotide is a fairly complex molecule. And they've given it this model so that the nucleotide is like a cloud, this cloud of electrons that surrounds a positive nucleus. So electrons are negative, cloud on the outside, positive nucleus on the inside. So you have this dipole, positive, negative. And then this cloud can move relative to the nucleus, kind of spin around it. And that can form an oscillation, a harmonic oscillation even. And so when two nucleotides come together and they bond, the clouds have to oscillate in synchrony, in the same frequency to be able to actually bond and stick together. Because if they're not harmonic, if they're oscillating at different rates, different frequencies, they're going to break apart. And so they've imagined the idea of DNA and the DNA helix. And what they say is that clearly, I love it when scientists start with clearly, clearly the chain of coupled harmonic oscillators is entangled at zero temperature, they say. And then they show that entanglement can also exist at room temperature. Room temperature is great. That's where a lot of things really exist. And so they've come up with this idea of a phonon. These phonons are basically these harmonic oscillations, and they're quantum objects. They can exist in superpositions of states and become entangled. And they have a wavelength that's similar to the size of DNA. And in all of this stuff adding up together, they basically, their main point is, without quantum entanglement, our DNA would probably break apart. And that quantum entanglement is probably essential to our DNA sticking together.
It seems like an entangled mess.
You think?
I mean, I don't know where it got separated from all matter can be entangled to, how it affects our DNA. I mean, it's just how all matter works then, right? If these entanglements are taking place on the quantum level all the time, and that's how all matter's made, it's being held together, then, it would affect DNA, hair follicles, remote control batteries, everything. Like, I don't know.
Well, I think that's the interesting point, is that for years and years and years, for a long time, we didn't even know what quantum physics was. And now we know what it is, and we're starting to dig into things more deeply. And for years, biologists were like, no, this quantum physics stuff, that doesn't play into what's happening here. But more and more ideas are coming out that really support this idea that quantum entanglement, quantum physics is tied in. I mean, it's tied into everything, and you can't get away. You can't get away from it. So I think it's a really good point that, everything is entangled probably in some way or another, and getting away from that is probably I don't know that we can get away from it.
No, everything is physics, which is cool, which is fine. Although I would counter one thing you said. I would say that not very many things exist at room temperature. I'd say that's very rare.
Okay, in the universe?
In the scope of the universe, room temperature, it's only in a couple places, and it's pretty much...
Okay, so the statement I made was a little vague. I didn't explain everything that I meant in the statement. I meant that a lot of things here on Earth exist at room temperature, and that life
as long as they're inside
a lot. Yeah, and if you're in a room
outside, temperature.
Oh dear. Yeah, but I just thought this was a really interesting story. The idea that physicists are trying to, fill in the gaps, trying to bring biology and physics together, trying to tie all of these ideas into a common framework, which, it's important.
Yeah,
it's all connected, man.
It's not sufficient to be a biologist solely as a biologist anymore. You really need to know physics to be on the cutting edge of biology. Yeah, it's absolutely necessary these days. Or so I've heard.
Or so. Yeah, this article was sent in by Gordon MacLeod, and it's in the Technology Review blog, the archive blog. It's just fascinating. Think of it. Just think of the implications. And then let's move on to one of Justin's stories.
So this is a tomato I grew from my garden, and it applies to this story like so. A Purdue University researcher has discovered the fountain of youth for tomatoes. Avtar Handa, professor of horticulture, found that adding a yeast gene can increase the production of a compound that slows aging and delays microbial decay in tomatoes. There's a giant tomato. So one of the things that just right off the bat, that when something says it delays the microbial decay, it means it's not as easy to be digested by microbes, which I'm not sure that already scared me right there. He says the results published is going to be published here in the early online version of the Plant Journal will likely transfer well to other fruits. He's quoted here, we can inhibit the aging of plants and extend the shelf life of fruits by an additional week for tomatoes. This is a basic fundamental knowledge that can be applied to other fruits. The organic compound, spermidine, is a polyamine. Anyway, it's something that you find in all living cells. Handa and Arturo Mato, a research plant physiologist at the U.S. Department of Agriculture Research Service and collaborator in this research, has shown earlier that these polyamines such as spermidine and spermine enhance nutritional and processing quality of tomato fruits. So this is, 1 week is a pretty significant addition to the shelf life. Here in the United States, probably not such a big deal because everything is, air conditioned to refrigerated truck to the market pretty quickly. Lots of places in the world, maybe tomatoes are unavailable because there's not enough, because it's only they even got 8 days longer, so a little over a week. Before there was any sign of shriveling compared to a non-transgenic plant. And decay and rot symptoms with fungi were still delayed by an additional 3 days. That's excellent. So if it increased the quality of the fruit, if a tomato goes to market, people won't buy it if it starts to shrivel. So if we can keep it from wrinkling, we can extend the market time of the fruit, which is also good for the middleman, the grocery store. Yeah.
Yeah, more chance to sell the fruity wares, right? For the grocer.
Yeah. And we can add this gene to the tomatoes or look at natural variation, select the cultivars that already have a high level of the gene expression. The only major roadblock now in getting these fruits to market, FDA labels that will have to declare the fruits to be full of spermidine. Now with more spermidine.
Yeah, this ties into a story that I'm going to bring up later as well. But the way that genetically modified organisms have to be labeled is if they have some kind of a substance in them, a gene that codes for a protein or enzyme or a spermazine, if it changes what the plant does or how it is in nature, then they have to label it. I mean, there's a high chance maybe somebody's allergic to spermidine. We don't know that. What? Justin's just laughing in the corner.
It's just too much fun. Allie, what do you got?
I've got bedtimes for the Japanese. Basically, in Japan right now, there's an environment ministry, and it's going on this campaign to urge people to go to bed an hour early, in hopes of reducing carbon emissions from electricity. The campaign claims that they could reduce the carbon footprint by 85 kilograms a year if everyone goes to bed and gets up 1 hour earlier. And the campaign is called the Morning Challenge. And they're also encouraging people to do healthy things with that extra hour, like do yoga or go for a jog and eat a healthy breakfast. One of the people in the ministry says, by going to bed early and getting up early, we can avoid wasting electrical power, which causes carbon dioxide emissions. If people change their lifestyle, we can save energy and reduce emissions. So this is just the latest campaign that the Japanese government is going for. And they've also recently done a campaign called the Cool Biz campaign, which urged people to wear short-sleeved shirts to work and in offices, and to not turn air conditioning lower than 28 degrees Celsius during the summer. So they're just going through a bunch of different lifestyle campaigns right now, because they have a goal of reducing the carbon emissions by 25% from 1990 levels within the next decade. So, yeah, they're just
work.
Yeah, I don't know.
No, it will have an end result effect of zero, and the reason being, when all of these people are conserving, the price of electricity becomes a little cheaper because there's more of it available, and it will get gobbled up by industry or by those who just found it too expensive to keep the lights on, who needed the lights on a regular, normal period of time.
That's a very Western viewpoint, Justin.
It's not a Western viewpoint.
Put yourself in the Japanese headspace.
No, this is energy economics. It has nothing to do with where you are in the world. As soon as you're conserving and not leaving your lights on all night, if everybody does it, then we say, yeah, there's a surplus of the energy out there. It's going to get used. The energy's been produced. It's being produced at maximum capacity all the time. Just means that the price of it goes down. So industry will use it more. If industry uses it more, there's probably going to be more growth in industry, right? And so they're going to need more electricity. So actually the end result is they could be fueling the power generation of or the power demand of the future even greater. They could be making a bigger demand for the carbon imprint.
Yeah.
Go ahead, Allie. Sorry.
Well, Pamela Sue Taylor actually sent this in, and she was saying that it might also increase the number of people being produced if everyone goes to bed an hour early.
Hey, that's an excellent observation.
Which could also, yeah.
Yeah,
also
especially if you send all these people to bed and they're just not sleepy yet.
Yeah. So.
I think the behavioral changes to try and conserve energy, I think that's probably one of the hardest things that you can do. I mean, you can have a governmental campaign to try and get people to do it, but how many people really are going to? And then, like Justin, you brought up, if you are able to impact even a slight percentage of your population, what is the end result? I mean, yeah.
0 or worse. And in fact, you look at the carpool lanes. You look at carpool lanes throughout the Bay Area, right? Carpool lanes everywhere. When it's really, really heavy traffic, there's a few cars zipping along, like, in that carpool lane. And the rest of traffic is sitting there like a parking lot. So you're actually delaying all those other vehicles, making them use more fuel, making them stay on the road longer. Thousands and thousands of vehicles. And the idea that the few vehicles that are carpooling were incentivized to do so, it's ridiculous. It actually has the opposite effect of what it was intended to do.
Although I feel like I've won a prize every time I have enough people in the car to carpool. Like, yes!
Oh, yeah.
Yes, yeah. I'm moving. It makes you feel good. It does. There's something about the reward system there. It's pretty good.
That's why I had kids. Just enough kids that I can just throw in the back and zip around. It's beautiful.
If you just tuned in, you're listening to This Week in Science with Dr. Kiki and Justin Jackson and Ali Debsky. So many fishy questions. This one ties into Justin's story from earlier. The FDA is considering right now whether or not to allow genetically modified salmon to be sold to people to eat. There's a company called Aqua Bounty Technologies that's been working on this special genetically modified strain of salmon for about a decade, and they've been trying to. Well, they've probably been working on it longer than that, but they've been trying to get it accepted by the FDA for about a decade. And they are just about at the point where the FDA is like, okay, you've got like 5 out of 7 of our check boxes checked. We're good with you. So they're getting there. Now, what have they done to the salmon? What is this particular genetic strain of salmon? It's an Atlantic salmon, and it contains a growth hormone gene from a Chinook salmon. And then it also contains a genetic on switch from a fish called the ocean pout, a distant relative of the salmon. So salmon normally have a very long growth cycle. It takes them about 3 years once they leave their home stream out in open waters to grow to full size when they finally are going to return back to their home stream and go spawn. It takes a long time. And part of the reason it takes a long time, longer than many other fish, is that they don't produce growth hormone when they're cold, when they're in cold water or cold weather. So what the pouts gene does, the gene that is the on switch, it turns on the Chinook salmon's growth hormone gene all the time. So instead of having this kind of slower, sometimes turned off growth cycle, this new Atlantic salmon will now just grow until it reaches full size in about 16 to 18 months instead of 3 years. And so the salmon is not going to be like some super giant Hulk salmon. It's just going to get to full size faster, which will allow the fish farmers to be able to have a faster turnover, and there'll be more fish, more salmon for people to eat faster. And they say, and I don't really know if I agree with this or not, but one of the people from the company, a Mr. Stodish, says that Ronald L. Stodish, he's the chief executive of Aqua Bounty, he says that one benefit would be to help supply the world's food needs using fewer resources. And I don't see how that would be true. I mean, you're growing fish to the same size, but you're doing it faster. So you're going to be growing more fish over time. So wouldn't that use more resources? Anyway. Yeah. So I don't know. What would people eat a genetically modified salmon? Would this be something people would be interested in? I mean, the question that comes to my mind is, how is this going to impact the environment? How is it going to affect wild salmon? If these fish are ever raised in ocean pens and not like somewhere on land far away from wild populations, if any of them ever escaped, wouldn't they have a leg up on the wild populations? Wouldn't this potentially be really devastating to natural populations?
There's a lot of stuff that eats salmon. I think it could be good. I think there's probably whales out there, the killer whales at least, dolphins, sharks especially, out there going, hey, bring it. What are you doing? Hurry up. We need some more salmon out here. You've been fishing them out of the river forever. You got them in pens. We can't even get to them. Release them. Fast growing. They'll be everywhere. Beautiful. I think the ocean wildlife would be all for it.
Yeah, I don't know. But the interesting thing about the FDA process to make this happen is that it's treated like a pharmaceutical. So even though it's a food, because it is genetically modified, they've applied their pharmaceutical rules to it. And so it's completely secret. So nobody can really see any data on potential environmental impacts. Anybody outside of the FDA, nobody can see this. There is going to be a period of public comment, and there will be some public meetings about it. But some people, biotechnology project director here in this article from the New York Times, Gregory Jaffe, Center for Science and the Public Interest, said that such meetings often do not give the public enough time to analyze the data. So, there are multiple questions going on here. And, maybe these tie into your special tomato as well, where, the way that the FDA is permitting these things is really the way to go. Are these things really, do we want to be modifying these organisms in this way for our food supply, potentially releasing them into the wild?
Why not?
I don't know. Or not, yeah.
Well, why not?
Why not?
Wouldn't we? We're just doing it faster. We did it with bananas and corn and all sorts of other things that we've cultivated over thousands and thousands of years and altered them from their natural state. We have altered the entire planet already. The land, at least, is completely altered from its natural state. Well, the oceans, too, and the way that we fished. Every time we fish any crop of fish, we're altering the natural balance of the ecosystems and everything else. The idea that somehow, because we're doing it on purpose and are looking at where it might go, as opposed to just having done it blindly without knowing that it would have any sort of side effect, well, gee, I think we're actually doing it smarter this way than we've ever done it in the past.
Yeah.
Well, also, just because you're doing it smarter doesn't mean that you're. Doing it faster doesn't mean that you're doing it smarter. Like all those other ways that they didn't know the effects, those had bad effects too.
Exactly.
So, but that's not really an argument as to why not. That's more of an argument as to why you should not. I don't know.
Yeah, it's more of an argument of trying to figure. I think there's so much more that we need to learn. I'm not against genetic modification per se. I think in terms of I don't know, but I think there's a lot more that we need to discover and understand about what we're doing before we're like, yeah, let's put this salmon out there. I don't know. Who knows? Maybe they'll save all the salmon. This might be the salmon's great last hope.
I still got to say though. We have like environmental waivers that go out to oil companies who want to drill in the middle of the Gulf Pacific, and yet we're going to hold up a salmon. I don't. There's no frame of reference here compared to what else are we holding up that we're doing in the world in nature. From any emission to anything else that we're putting out into this world that's not natural, that we had something to do with.
Everything's natural.
I don't think fish is going to upset the apple cart of planet Earth. And then we can take that snapshot, that clip right there. We can save that clip. We'll play it back 20 years ago when
that's right.
The ocean's full of salmon. People are afraid to go out to the beaches.
Freaking salmon!
Everything. They're learning to walk on land. Mutant salmon. Why didn't we have the foresight? We could have prevented this.
Hey, did you have some kind of Robo-Fish story or something?
I have lead scientists that have created the first convincing robotic fish, which is not just convincing to people, but convincing to fish. So they've been playing with this fish for a little while now. Let's see. It's a computer-controlled replica dubbed Robo-Fish by its creators John Dyer, Dr. Dean Waters, and Natalie Holt. It is a plaster cast model of a 3-spined stickleback with an acetate fin painted to mimic the coloration markings of the real fish. And so what they've been doing with this is testing out group mentality of a shoal of fish. So they'll take this little Robo-Fish and they'll have them zip along near the front or the outside and go a little faster than the other fish, and then make a right-hand turn or a left-hand turn and see if the other fish will follow. And sure enough, when the fish are in a shoal, when they're in a group together, they do tend to follow the movements of the most aggressive fish. So this Robo-Fish was actually leading them to the left and to the right, and it was only really effective when the fish were nervous. I think that's a different fish. That's like maybe the prototype. That looks nothing like a fish. I've got the picture I've got here has a little. That's the. Where's the? I can't tell my left from my right.
There you go. You're good. You're good. We saw the fish. It looked like a little fish.
So, but this really only worked. The group mentality of following the most aggressive fish only worked when the fish were nervous. So the fish had gotten transplanted into a new tank. They put the Robo-Fish in there, and they would sort of follow. The group would sort of large portion of it would follow the Robo-Fish and its aggressive motions to the left, to the right, and exploring around where they'd been transported into. Once they got comfortable, once they weren't stressed, they just kind of looked around on their own and lost the group mentality, which I think there's a psychological experiment in there somewhere. One of the other interesting things they found is it was always assumed that because the movements in those shoals of fish, if you ever see them, they're so quick. They're just very agile. It's like a flight of birds. One turn, they all seem to turn direction at the same time. And the idea was you were following the motions of your closest neighbor, and that the closer they were, the more in sync you would be with them. Interestingly, what they found was it didn't matter how close or far away Robo-Fish was, but the nearest fish to them, regardless of how close, mimicked its motions the most accurately. That's pretty wild.
I think it's pretty cool.
So now we have these mutant salmon, right? They're going to let them out into the ocean under the just and see what happens plan.
Right, and then put out the Robo-Fish to control them.
The Robo-Fish. See, we just put the Robo salmon out there, and we can, bring them home at night like a herd of cattle.
Yeah, I think that could work. That's good thinking. That'll totally work.
Fish ring.
Either that, or you can teach them, use the Robo-Fish to teach them the RoboCop dance moves, the Robo slide, slide.
That's like the saddest mode of fishing, though. If you just sent out your little Robo-Fish and then you tricked them all into following you to their death.
That's what fishing is, Allie.
No, but that's a sadder version of it.
Go look at a fishing store. They got all this tackle that looks like little fish, and so the bigger fish will eat that little fish, thinking it's a little fish. But
they think they're getting out of danger. They don't think they're attacking another fish. But yeah.
They're the aggressors. They're like, I'm going to make a meal out of you. And then it's like...
Exactly. So they kind of had it coming, but not here. They just think they're following their leader.
Yeah.
That's right. Follow the leader to your doom. That's awful. All right, everybody. This is the end of the first half of This Week in Science. We'll be back in just a few moments with more This Week in Science. Stay tuned.
Shows the way to go.
would like to thank Audible.com for sponsoring this episode of This Week in Science. Audible.com is the leading provider of audiobooks with over 75,000 different titles in a variety of genres. And Twis has found many science-based books in the Audible library that we love and that we enjoy. So take our pick of the week, and I did have a pick of the week that's been my pick of the week forever, but just at this very moment, I thought that maybe I should try and change it to a different pick of the week because our Twis book club book of the month will be changing. It's almost July. So audible.com is offering you a free audiobook download if you sign up for an account with them. You get one free audiobook download just for signing up, which is pretty awesome. I mean, that's at least a few dollars right there. And I suggest that for this next month's book of the month, you try out The Weather Makers by Tim Flannery. I think it's in their library. Let me check audible.com. I'm going to check right now. Oh, let's see if I can actually spell. That might make a difference. But The Weather Makers by Tim Flannery is the Twis Book Club book of the month, and it's talk about the climate, talk about weather and how human intervention plays a role in the weather and climate that we see. And he uses a lot of scientific evidence. It is a science-based book. So you can read it and agree with it or not agree with it, but it's definitely an informative read. So I've decided the typing and talking at the same time is not the best right there for me. The Weather Makers, yes, by Tim Flannery. It is an audiobook in there. How man is changing the environment, changing the climate, and what it means for life on Earth. So try that out as our suggested pick of the week for audible.com. All you have to do is go to audiblepodcast.com/twis. TWIS. That's audiblepodcast.com/twis. Sign up for an account and get your free audiobook download. And if you don't want it to be Weather Makers and you don't want to be a part of the Twis Book Club, that's fine. Pick something else. You still get a free book. So do it right now. Thanks a lot.
Answers lie somewhere within this scattered plot. Our first assumptions were correct. Disprove the rest. It's hard. The methods and hypothesis and patience are the only things I need. Put on a pair of goggles and go looking for the things I couldn't see.
And we're back. This is This Week in Science. If you just tuned in, it's just a button. I've just got random things on my desk here. Firefox buttons. Swag for the open web.
I have the world in my hands.
Oh, you do.
I need
That's fabulous. And you changed.
I want to get a Gallagher thing. Yeah, I was feeling all like controlled by the man with that noose around my neck, man. So I took it off.
Awesome. All right, we'll bring some news. You got some science news?
Me?
Yeah.
What is the most dangerous time and conditions to be driving your car?
Dusk when you're drunk and and you don't have.
Okay, wait. I should have
can't reach the steering wheel.
Season? What's the most dangerous season?
I don't know.
Drinking with just staring with your feet and trying to hum a show tune is considered illegal in some states. What is the most dangerous time of year to be driving your car?
Winter?
Well, if you believe winter,
Spring?
you're in line with 83% of Americans.
And?
The correct answer, well, if it was winter, pretty boring story. It's summer.
Summer? Really?
Yeah. In fact, the absolute peak of danger is coming upon us very quickly. It is 4th of July weekend. is the most dangerous time to be driving.
Right.
Possibly because people are drinking.
And shooting fireworks into your car.
Then people are relaxed. According to this study, they think that the reason that so many more accidents, let's see, where's the actual numbers? 1 out of 5 Americans, live in, this is mostly for rural areas here, 1 in 5 live in rural areas. About 6 out of 10% of highway deaths occur on roads that are considered to be rural. And most of these, a high percentage of these, occur during the summer. They think because people are driving faster, they're more relaxed, less attentive, and 4th of July weekend, possibly drinking. So be very careful out there on this holiday weekend. And definitely, you know, if everybody out there who's not in the diamond lane, if you all took the diamond lane together, you know, all at once, all together, just did it, just went, said, hey, we're gonna like carpool diem, seize this lane and just scoot over. What are they gonna do? Write everybody a ticket? It's gonna be like driving 80 miles an hour on the freeway. They pull over somebody, sure, once in a while, but everybody's going 80. They can't get you all. They can't get all of us. I say we just start taking that extra lane.
I call tangent on you.
Oh yeah, I slipped into that one.
I call tangent.
Yeah.
But I think it's fascinating how everyone, I mean, the weather is what everyone perceives as being a huge influence. So winter weather, the storms, the ice on the road, the snow, mountain roads. I don't know. But it's summer. That's amazing. Yeah. More people on the roads, most likely. More drunk.
Also, it's hot, so maybe people are angry. Road rage.
People do get angry in the summer.
Mm-hmm.
Most wars are apparently started in the summertime.
Interesting. Let's get into a little bit of this week in history. This week history.
In science history?
Yeah, science history. Yeah, I missed a word there. This week in science history. Speaking of history, I actually pulled this from a newspaper.
Okay, wait, hold it up. I can't see it. Okay. Future. It'd be easier if you read it.
Yeah, I'll read it for you. So this is from the Washington Post, but I actually found this in the San Diego Tribune, which is interesting in itself. But Robert Boyle, a chemist from the 1660s, is part of a celebration of the Royal Society of London. They're running a 350 years of science celebration and memorial until November at the Society's headquarters in London. So if you happen to be going on a summer trip or whatever, you're interested in the science-y stuff, Royal Society might be a cool little stopover for you. Additionally, they're dusting out their dustbins of books and old records and found a whole bunch of papers of Robert Boyle's. And he wrote this document that's full of predictions that have actually come true. He is honestly one of the first science fiction writers. The stuff that he has come up with are just amazing here. So if you read this list, this document is actually going to be available for you to see there. So some things have not come true, such as the transmutation of species. We haven't really gotten there yet, but we do have chimeras and potentially GM salmon. But I guess he didn't want to brush his teeth. So he had a wish for the recovery of youth, or at least some of the marks of it, as new teeth, new hair colored as in youth. Other samples are the prolongation of life, which we definitely have. He also had the art of flying, airplanes, right? The art of continuing long underwater and exercising functions freely there.
I don't know what functions do we
I don't know.
really function underwater? He's talking about peeing in the pool?
Maybe.
In the future, man will pee in the pool because I certainly haven't done so myself.
Yeah.
Ever.
Let's see. The cure of wounds at a distance, the cure of diseases at a distance, or at least by transplantation. It's there. The emulating of fish without engines by custom and education only.
The what?
Yeah, the
Wait, say
language
that
in
one
some of
again?
this. The emulating of fish without engines by custom and education only.
Is that the robotic fish?
I think it
Did he
might
predict
be.
the Robo-Fish?
Yeah, he predicted.
Wow.
I know.
That's impressive.
Yeah, the acceleration of the production of things out of seed. Let's see, the making armor light and extremely hard, which we have. The use of, let's see. Here's a good one. Potent drugs to alter or exalt imagination, waking, memory, and other functions, and appease pain, procure innocent sleep, harmless dreams, etc.
Wow, yeah. Pharmaceuticals. Yeah.
He wanted pharmaceuticals. He was ready for it.
And look, wait, check it out. Wait, where's that picture of this guy? This guy's got like long hair.
He's got hair like me. That's great.
And he didn't. Wow.
It's great.
He wanted it to be less gray.
Yeah, and then the
Someday
last
there will
one.
be hair dye, a product called Just for Men. Revolutionize men's hair.
Revolution! Yeah, one of the things about this is he's predicting all this stuff, and he had these writings of all these things that he wanted to see come true. And this was very shortly after, if even when this was written, if even before the word science had even been popularized, was even in common usage. So he was really thinking ahead of his time, and it's just fascinating. I want to go to London. I want to see his stuff. I wants to see it. Yeah. Allie, what story did you have? You had
I've got a cancer and bubbles story. So there's in the University of Leeds, they're about to attempt to create this technology to deliver cancer drugs through the use of bubbles, gas bubbles in the bloodstream specifically, and then to activate the delivery with ultrasound. They got the idea from using bubbles to provide a clearer image for ultrasound scanners. So, because if it's like really tiny bubbles injected into the bloodstream, it can show up better on the ultrasound. But at certain signals of the ultrasound, the bubbles will burst, and so they got the idea of doing that intentionally and filling the bubbles with the cancer drugs and waiting till they get to a specific place in the body and then zapping them with an ultrasound and releasing them.
Brilliant.
Yeah,
That's
it's
smart.
really interesting because, a lot of cancer drugs are really toxic, and I mean, that's the point of them, but that they kind of kill all the cells rather than just the cancerous ones. So it's a kind of interesting idea. They still have to figure out, they're planning to not just do the drug, but the drug and an antibody in the bubble, and the antibody should be one that would be attracted to the tumor cell, wherever they're trying to go.
Right.
So they're still working on that. A lead researcher of the study, Professor Evans, says, a number of research teams are looking at the possible uses for microbubbles, but with the breadth of expertise available at Leeds, we're in a good position to make a breakthrough. For the technique to be a viable clinical and commercial option, we not only need to find a reliable way to attach the drugs and antibodies, but we also need to be able to manufacture the bubbles in sufficient numbers, of the right size, and with consistent properties.
Yeah. I think something that people are talking about a little bit in the chat room as well is the question of whether or not these would be big enough bubbles. You called them micro bubbles. They're concerned about them being big enough to cause embolisms, or whether they're air bubbles that could actually be dangerous to people in any way.
Yeah, they're filled with they're supposed to be filled with fluorocarbon gas, which it says it has the advantage of not dissolving easily in the bloodstream. But yeah, it has to be really tiny bubbles, and that's part of the problem actually, is that they need to find a way to make the bubbles consistently and at the small enough size. I guess the ones that are already used in the imaging for ultrasound are 1,000th of a millimeter across, so that's pretty tiny. Yeah, and I guess currently they just have methods to shake up a liquid and create those bubbles, but they're all kind of different sizes, and so they don't really have the right value. And I think they would have to be the same size because then they could get the exact ultrasound pressure or level that they would need to burst them.
Right.
Yeah, and so one of the Stephen Freer is the ultrasound guy, basically, and he says, the ultrasound wave makes the bubbles resonate, vibrate, and finally burst. By changing how we code the electrical excitation signal, we can image and verify how many bubbles are at the site to ensure we administer the right drug dose before we burst them. This means we can use ultrasound not only to detect and image the microbubbles, but to critically rupture them, delivering the drug payload in a controlled way. So they would kind of watch where the bubbles are going with the ultrasound, and then, maybe at a lower frequency, and then once they're in the right place, they would crank it up to the exact amount that would burst it.
Blammo!
Yeah, so it's a pretty interesting idea. They just have to develop it a bit more.
Yeah, I love all these ideas for direct, targeted delivery of drugs. So it's just finding new ways to limit the way that the body is affected by these really toxic chemicals that are killing the cells. Because until we have better drugs, we have to work with the ones that we have. And so why not find ways to really get them to where the tumors are, as opposed to full body chemotherapy where you just are sick and you feel terrible. I mean, this could be so much less invasive. I mean, it's invasive, but it's, I guess less invasive to your life.
Yeah, I wonder about the microbubbles too. I mean, I guess they use them already in the ultrasound technique, so they must not, be harmful. Because I've always heard that too, that, if you get a bubble in your bloodstream, it's like cause an embolism. It's really dangerous. So maybe it's just that they're so tiny or whatnot.
Yeah. I think the size of the bubble makes a big difference.
Yeah.
If it's a small bubble, I mean, the question, if they're already using it, but the fluorocarbon gas, I guess that's the question, is how long does that last in the bloodstream? Unless, is it all going to go where, not all of it is going to go where the tumor is, and you're not going to burst all of these bubbles in the blood. So what is going to keep existing? Where's it going to go? And how is it going to affect areas of the body that it does end up?
Yeah, that's true too. And I think they can focus the ultrasound, I guess, enough to just activate in that area. But then, where does it go? And I assume that it dissolves eventually. It just says it's slower to dissolve. But I don't know.
I don't know. I can't wait to hear more about it.
Yeah.
And if you just tuned in, this is This Week in Science. Justin, you got any more stories?
Researchers at the Stein Institute of Research on Aging and Rady School of Management at the University of California, San Diego School of Medicine have determined that while watching television may not turn your brain to mush, mushy brains watch more television, which is, I'm probably going to get in trouble for this. We found that older people spent a great deal more time watching TV than younger people, yet they enjoyed the experience less, says the first author, A. Depp, PhD, assistant professor of psychiatry with UCSD's Stein Institute on the Research of Aging. While the study underscored what the study underscored is the alternatives to television as entertainment are needed, especially in older adults. So they basically discovered they need to turn the TV off and send the old folks out to recess. The study took a look at 3,092 Americans aged 15 to 98. And this was a survey of data collected back in 2006. Adults over 65 reported spending 3 times more of their waking hours watching television than did the young adults. Older adults did not seem to experience the same stress buffering effects the younger adults did from watching TV. And TV use among older adults, unlike time spent on other leisurely activities, was related to a low life satisfaction. So those over the age of 65, about 25% of their time is spent in front of the television. I think that includes that's not 25% of their waking time, but 25% of their time on planet Earth at that point.
Too much. Go outside, get some vitamin D. It'll keep you from breaking your bones. Good for you. How about some interaction with people?
Yeah.
There's got to be some kind. Yeah, there's just got to be a spiral in there. You spend more time watching television, and then you end up kind of depressed, and it doesn't entertain you anymore. But you keep doing it and cycling and
side effects of television. Yeah. Side effects of television. There's no warning label. Right? The TV doesn't have a little Surgeon General warning on it.
Nope.
They don't disclaimer when you turn on the television the health risks associated with prolonged use. But here they are: cardiovascular health, bone health, cellular function.
Yeah.
Function properly. It's linked to greater risk for obesity, type 2 diabetes. General overarching lower life satisfaction is reported from heavy television viewers. Less frequent engagement in social and physical interactions. And increased risk for dementia. Yay, television. Wow. And the older you get, the more you watch and the less you enjoy it. That's the other thing. The study indicated that older adults reported lower levels of positive emotions while watching TV, which was almost the complete opposite of the younger adults. So they enjoy it less and less, have nothing positive to say about it, really, and yet this becomes their life. But again, I think this is one of those things that this is, I think, a generational thing. I mean,
possibly, and it could also be an age thing where as you become older, your energy level goes down.
It can't be an age thing.
Maybe you're injured as you get older. There are all sorts of things that happen health wise as you get older to keep you from doing stuff and will put you in front of that television more and more often. Right. So there are a lot of factors that need to be taken in.
If you look at generations previous, before television, there weren't a lot of people staring. Yeah. So I think the future generations, just as we are used to being able to Skype and be able to communicate. So if we do get sent to the old folks home, we'll probably still have our social media there, right? We'll still have our Facebook updates. We'll still want to be able to connect via webcam and talk to loved ones. I think also, television is becoming less and less critical to entertainment. And video games are, for instance, taking over more and more. Video games, you don't just sit there and watch. You're not just this passive viewer of a video game. You have to be interactive with it. You have to play with it. And now the games are online, and people are socializing.
And you can be interacting and all sorts of other stuff. We are getting to the end of our show, so we got to wrap it up really fast so we can end on schedule. We can talk about this at our post-show wrap-up, Justin. We can keep this moving in just a minute. Hayabusa update. In Popular Science, I saw an article that Hayabusa, they're opening it up, and they have found the presence of low-pressure gas inside the capsule. They don't know exactly what it is or where it came from yet, but there's something in there. We'll be giving you more updates as we find out more. On next week's show, we will be here on Thursday. That's right. Twis is broadcasting.
3 days from now? Very soon.
2 days from now. We're going to be broadcasting live on Thursday nights, 7:30 to 8:30 p.m. Pacific time, starting this Thursday, July 1st. And in addition, I believe Allie is going to be bringing us another Twis Decade in Review topic, epigenetics. So definitely tune in Thursday. Yeah. Yeah, and it's time for the new book. Twis Book Club, as I mentioned, is the July book of the month is Weathermakers by Tim Flannery. You can visit twistbookclub.ning.com for book information. Shout outs to Gord McLeod, Monkey, Shannon Mortimer, Coder Monkey, and Sean Highland for sending in stories, and everyone who wrote in asking about our iTunes feed problems. Hopefully the fixing happens soon. But in the meantime...
Thank you for listening. We hope you enjoyed the show. Twis is available as a podcast. You can go to our website. Wait, don't go to the website. Can we go to the website? Do we have a website?
Not yet.
We have a website. We had a website that was www.twis.org. We'll have a website again, a new one that'll be different, where you can also do the same stuff. But we want to hear from you. So in the meantime, you can email us Or Google
You can.
us.
Or Google us. That's right.
Yeah.
You can find
Google
us in
iTunes even.
You can subscribe to us if you search for us in iTunes, This Week in Science in iTunes. You'll be able to find us. For more information on anything that you've heard here today, show notes will be availavailable at our website, twis.org, when the website is available. And we do want to hear from you. So email, Twitter. You can Twitter us at Dr. Kiki or at Jacksonfly.
Be sure to put Twist somewhere in that subject or you will get spam filtered into oblivion. The websites. You can contact. Oh, you already got that part. Wait, you skipped.
You skipped stuff too.
Yeah,
I was just getting you back.
All right. So we'd like to thank Allie, our industrious intern, and Jammer B, the engineer extraordinaire, for helping us make this show possible. We'll be back here next week. No, we'll be back here next Thursday.
Yeah,
and
Thursday.
Join us for more great science news. And if you have learned anything from today's show, remember,
it's all in your head.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
That's right. Thanks, everybody, for watching. People are wondering about the Thursday move. We are not kicking Eric out of the Tech Talkback slot. We are moving things around. So Eric is going to be after us. We will be 7:30 to 8:30 on Thursdays, and Eric will be from 9 o'clock to 10 o'clock, I believe, is what it's settling out to be. I think that's what it's going to be. Yeah.